use variation of parameters to solve the given system. So you have this system in to use parameter method. Here's the guideline for you. So first you need to find homogeneous solution, then find non-homogeneous solution, and your final answer is the combination of those two. Okay, so let's go over it step by step. First, you need to have a minus lambda I. So because I'm familiar with this, so I didn't write it down, but for some of you who cannot see it, I have to write it down in case you get lost and wonder where did I get these. Okay, so a minus lambda I is equal to this. Let's call this matrix A and then subtract it with lambda. Okay, then find the determinant of a minus lambda. It gives you this one, set it equal to 0. Solve for lambda, you will get complex eigenvalue. Now for lambda equals positive I, plug it into a minus lambda I, you will get this matrix augmented with 0. From second equation, I know that k1 is equal to I k2. If I choose k2 1, then k1 is I, then vector k is I1. Okay, so since this is a complex eigenvalue, you don't actually need to solve for the other lambda because it's just the complement or the conjugate of this one. So homogeneous solution is equal to C1 times the real part of vector k, which is 0, 1, times cosine t, y cosine t, but not cosine 2t, 3t, because this actually cosine 1t, y1, because it is the imaginary part of lambda. So you have 1, so that's why you have cosine t. Subtract the imaginary part of vector k, which is 1, 0, times sine t. Okay, so that is your vector x1. Now for vector x2, you have second solution, you have c2 times. Okay, so duplicate this one and then rewrite it over here. Here's a few changes. So over here you have the left side you have negative, right side you should have positive. Cosine side stay the same. For these two vectors, you swap their position. Okay, so bring this over here, bring this over here. That gives you the second solution. Okay, and then if I multiply these together and then simplify it, it gives me this matrix. It gives me this answer. Okay, so that is my homogeneous solution. Now let's find the non-homogeneous solution. So similarly, like a minus lambda I, first I need to have this matrix obtained from homogeneous part, which I call function phi of t. Okay, so you exclude c1 and c2, put the rest into a matrix. Okay, and then you need to find the determinant of a minus lambda I, which is -1. Then its inverse is equal to 1 over the determinant times this matrix, but you need to change something. So in upward diagonal line multiplied by -1, downward diagonal line you are going to switch their position. So bring this down, bring this up. Okay, so it gives you this matrix. Now you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this one, secant t0. So multiply them together, it gives you this one, negative tangent t found 1. So here's a note, do not switch the order here because it will give you a different answer than this one. Now once you know your u prime of t, the next step is to find the integral of this one, which gives you this matrix. Integral of negative tangent t is negative natural log of secant t. Integral of 1 is just t. Okay, so the negative natural log of secant is the same as natural log of cosine t. Okay, so your non-homogeneous part is equal to phi of t times u of t. Multiply them together, it gives you this. Again, the order here matters. Okay, so do not change the order here, otherwise you will get a different answer, or I would say incorrect answer. And your final solution is equal to c1 times vector is equal to homogeneous part plus non-homogeneous part, which is the combination of this one and this. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.